Okay, today we are going over 9.7, probability of multiple events. So the first thing we're going to talk about is going to be whether two events are going to be independent events or dependent events. So we should think of the word independent and dependent and what those mean and what we think of when we hear those words. So when we hear the word dependent events, we should think of dependable or depends on, something like that. So if it's a dependent event, it's when the outcome of one event affects the outcome of a second event. And therefore, independent events will therefore be when the outcome of one event does not affect the outcome of a second event. So we have dependent events, it affects it. Independent events, they do not affect each other. So to go over a few where we're classifying events, we'll have either they are dependent or independent events. So if we roll a number cube and then toss a coin, we should know that these are not going to affect each other, one or the other. So therefore, they're going to be independent from each other. Since the two events do not affect each other, they are independent events. If we pick a flower from a garden and then pick another flower from the same garden, well, since it's from the same garden there, then that means that they are going to be dependent events because the first one will affect the result of the second pick. Okay, so moving on here, if we are looking at independent events and we want to find the probability of A and B, then that means that we're going to find the probability of A times the probability of B. So we keep in mind independent events, they do not affect each other. And so therefore, if we take an example of the probability of A is equal to a half and the probability of B is equal to a third, then therefore the probability of A and B would be to multiply these two, which would give us a half times a third would be 1/6. And that's finding the probability of A and B when they're independent events. Okay, we're now going to talk about mutually exclusive events. So don't get confused with these terms here. We have mutually exclusive events. We should have this written down here. And mutually exclusive events is just when two events cannot happen at the same time. So if it cannot happen at the same time, that means they are mutually exclusive events. And that means, for example, if I'm going to take a number cube and I am looking at the probability of an even, or the probability of an odd, then that means they cannot happen at the same time and they are therefore mutually exclusive events. So if they're mutually exclusive events and they cannot happen at the same time, that means that the probability of A and B is therefore always equal to 0. All right, moving on here, we're going to say if these are mutually exclusive and explain it. So rolling a 2 or a 3 on a number cube. So you want to ask yourself, can this happen at the same time? When I roll a number cube, can I have this happen at the same time on one roll? So we should say, no, it cannot happen at the same time. And since it cannot happen at the same time, that means that these are mutually exclusive events. Okay, since you cannot roll a 2 and a 3 at the same time, the events are mutually exclusive. Here's another one here, rolling an even number or a multiple of 3 on a number cube. So we need to ask ourselves, can this happen at the same time? Well, the even numbers on a number cube are 2, 4, and 6. Multiples of 3 on a number cube is 3 and 6. So since we got a 6 for both of these, this means it can happen at the same time. If we roll a 6, That means it's even, and it's also a multiple of 3. So since it can happen at the same time, it means these are not mutually exclusive events. So by rolling a 6, you can roll an even number and a multiple of 3 at the same time, so the events are not mutually exclusive. Alright, so moving on here, we're going to look at the probability of A or B. The probability of A or B. Alright, so we're going to start off by looking at when they are mutually exclusive events. If they're mutually exclusive events, it means it cannot happen at the same time. So, just like when we were talking about the probability of rolling a 2 or a 3. So those are mutually exclusive events, and we would find that, for example, if we said the probability of rolling a 2 or a 3, then these are mutually exclusive events because it cannot happen at the same time. So therefore, we would say, what is the probability of rolling a 2 plus what is the probability of rolling a 3? And there's only one side that has a 2 out of the 6 sides on the number cube. Plus there's only one side that has a 3 out of the 6 sides. We can add these. 1 plus 1 is a 2 over 6. And we can reduce that to 1/3. And that's how we would find the probability of that. Okay, if we're looking at when they are not mutually exclusive events, just like the other one, the second example on the previous slide, when they are not mutually exclusive events, what you're going to have to do is you're going to have to subtract off what they share. So it's a very similar formula. This is probability of A plus probability of B. We have that in here. Probability of A plus the probability of B. And then we have to subtract off the probability of A and B. For example, if we had the one that we did before, which was the probability of rolling an even or getting a multiple of 3, then I would say, okay, that's going to be the probability of an even plus the probability of rolling a multiple of 3. And since we said these are not mutually exclusive events because it can happen at the same time, we have to subtract off when it's going to be even and a multiple of 3 because we don't want to count that twice. So the probability that it is even, well, that's going to give us the even ones will be, we'll have the evens of 2, 4, and 6. So that's 3 out of 6. Multiples of 3 is 3 and 6. So that's 2 out of the 6. And when it's even and a multiple of 3, that will be the number 6 is both even and a multiple of 3. So we have to subtract that off, which is only 1 out of the 6, because we can't make this 6 come up twice. So we'll have 3 plus 2 is 5. 5 minus 1 is a 4 out of 6, and we can reduce that to 2/3, and that will be our probability of getting an even or a multiple of 3. Alright, so moving on here, we can do one more of those. The probability of an odd or greater than 2. So we first want to see, is it mutually exclusive or not? So we want to say, can we have an odd and can we get a number greater than 2 on the same roll? And we can, because the numbers for 3 and 5 are both odd and greater than 2. So it's not mutually exclusive events, and we're using this formula here. So we're going to say the probability of getting an odd plus the probability of getting a number greater than 2 minus when it's going to be odd and greater than 2. Okay, so the probability that it's odd, the odd numbers on a number cube are 1, 3, and 5. The numbers greater than 2 are going to be 3, 4, 5, and 6. Odd and greater than 2, okay, well, when it's odd and greater than 2, that's going to be 3 and 5. Okay, so we had 3 out of the 6 numbers were odd. We had 4 out of the 6 numbers were greater than 2. Minus 2 out of the 6 numbers were both odd and greater than 2. So we have 3 plus 4 is a 7. 7 minus 2 is 5/6. All right, moving on. If we look at one where we're going to have the probability of events for looking at different fruits in a fruit bowl. So we want to look at the probability of getting an apple or green. So the probability of that would be, we want to see, can that happen at the same time? Well, since we have 2 green apples, we know it can happen at the same time, and then therefore these are not mutually exclusive events because it can happen at the same time. So we'll say we're going to find the probability of getting an apple plus the probability of getting a green fruit minus the probability that it is an apple and it is a green fruit, hence a green apple. Okay, so how many apples do we have? We count all of the apples. We have 3. We have 3 plus, okay, hold on here. Okay, so we're counting all the apples here. 3 and then another 2 here. We have 5 out of, there's 3, 5, 6, 7, 9 fruits here. So 5 out of 9. Plus, how many green fruits? We have 2 plus a 1, that's 3 out of 9. Minus how many apples that are green? 2 out of the 9 because there's 2 green apples. 5 plus 3 is an 8, and 8 minus 2 is 6 out of 9, which we can reduce. We could take a 3 out of both and get 2/3 here. Finally, for this last part, all you're going to do is you're going to just plug these in. Since it says that these are not mutually exclusive events, what you're going to do is you're just going to plug it into the formula of C or D will be equal to the probability of C plus the probability of D minus the probability of C and D. So you just plug these in. We can do one here. This is number 1 and number 2 and so on. So we can plug one of them in. Let's say we do number 3 here. So if we are trying to find this one, we could say, okay, I'm just going to let that be an X for now, and then we'll find out what that's equal to. All right, so the probability of C or D, we are told, is 13 over 15. So I have 13 over 15 is equal to, probability of C, we're told, is 2/3 here. 2/3. The probability of D is 3/5. Okay, so plus 3/5. Minus the probability of C and D, that's what we're trying to find, so minus X. So when we're doing problems like this, the easiest way is to multiply by the least common denominator, which is what we went over in 9.6. So I'm going to multiply everything by the least common denominator, which is a 15. So I'm going to get 15, coming down here, so we have a little bit more room. I'm going to get 15 times 13 over 15 is equal to, multiplying it to every numerator here, 15 times 2 over 3 plus 15 times 3 over 5 minus 15x. Okay, now we'll cancel what we can here. We'll cancel the 15s and be left with 13. 15 over 3 is a 5, and 5 times 2 is 10. 15 over 5 is a 3, and 3 times 3 is a 9. And nothing can cancel here. So, combining like terms, I have a 13 is equal to 19. Whoops, this should be a minus x. 19 minus 15x. Okay. Then we'll subtract 19 from both sides. We get a negative 6 is equal to negative 15x. Dividing both sides by a negative 15. And we get x is equal to a negative divided by a negative is a positive 6 over 15, which will reduce to, we could take out a 3 from both 6 and 15, so we'll be left with 2 over 5. And that's how we solve it when we are given certain terms here and it tells us that they are not mutually exclusive events.